Using a Cyberware 3D laser range scanner, we can capture part of the geometry of an object. By scanning the object from multiple viewpoints and combining these scans using a zippering technique developed by Greg Turk and Mark Lavoie, we can produce a complete mesh for the object. Here we show Turk's program preparing to zipper together 2 scans of the bunny. Initially, we must register the Polhemus sensor to the mesh. We use an iterative method developed by Paul Bessel, which produces a shear-free transformation between the sensor coordinate system and the mesh coordinate system. Bessel's method requires us to collect many points along the surface of the object and perform an initial alignment of these points to the mesh. The advantage of this technique over others that use 2-dimensional devices for input is that in our system it is always clear where the mesh will be painted. The physical object provides a force feedback guide telling us exactly which parts of the mesh our paintbrush will affect.
Volume sculpting is a modeling technique based on free-form interactive sculpting of a solid material. The 3D volumetric model is represented in a 3D raster of voxels, where each voxel stores local material properties such as color and texture. In this video, the process of volume sculpting a chair from a block of wood is shown in real time. Sculpting is done by moving 3D voxel-based tools within the model. A user first specifies on the projected image the region to be sculpted. Then, by adjusting the depth of the extrusion, the 3D tool volume is generated on the fly. The 3D tool volume is volume sampled to prevent object space aliasing. Note that since view-independent attributes such as texture are stored within each voxel, there is no additional processing needed for texture mapping. Then, a rectangular region is drawn to cut out the bottom portion of the chair.